Hello, this is a presentation about OVS-DPDK shared mempool improvements. So OVS-DPDK pre-allocates a number of buffers known as mbuffs into a group or a pool known as a mempool. And this avoids allocation for packets on the data path. There's two operating modes, shared mempools and per port mempools. Shared mempools can be used by multiple ports, and the sharing is based on NUMA and MTU. They're larger mempools, and this is the default. Port mempools can only be used by a single port. They're smaller mempools and might be useful for a small number of ports, but they don't scale too well. So typically people use the shared mempools. And there's been two recent improvements in shared mempools. User configured shared mempools, which is the more important of the two because it requires some user interaction to get the benefit of it, and delayed vhost mempool creation, which is something that happens under the hood. We'll give it a brief mention. Okay, so user configured shared mempools. So if we take the example where we add a port for a physical NIC with DPDK, so in this case 50 with an MTU of 1500, we need a mempool for that physical NIC because we need to populate the receive rings on the NIC. So we create a mempool seen here in blue, and it's populated with mbuffs, which are represented by the white rectangles. Now, if we add another port, phi1 MTU of 1500, well, we can share this mempool because, as we said, it's based on NUMA, and we'll assume same NUMA here, and MTU. So what happens if we change the MTU of one of these ports to 9000? So we can't continue to use the 1500 MTU based mempool for phi1 in this case. And the reason is because the actual mbuffs in that mempool just don't have enough space to handle the 9000 bytes that might be present on phi1. Okay, so we need to do something else. So we need to create a new mempool to deal with phi1, a 9000 MTU based mempool. So what's wrong with this picture here? So there isn't necessarily a problem, but there is an optimization. So phi1 with an MTU of 9000 we know can't use the 1500 MTU based mempool because there isn't enough space. But phi0 with an MTU of 1500 could use the 9000 MTU based mempool. But that's not being done at the moment. So could we do this now at this point? So, well, if we want to do this, the first thing is we would have to create the 9000 MTU based mempool before we could switch phi0 over to it. So we wouldn't want to remove the other one first. So at least for an interim period, we would still want to have both of the mempools present. So while we might save memory, afterwards, the user would still have to provision to have for that interim period where both mempools are needed. The other thing is, of course, we'd have to stop phi0. So we'd have to repopulate the rings. We have to stop the device. So that's not a good thing, but it's especially not a good thing when it's based on an MTU of a different port changing. Okay, that just doesn't sound like something that we would want to do. Okay, so could we have done this instead? So when we initially added phi0, could we have just said, okay, well, we're going to create a mempool with 9000 because that's going to be more resilient and more shareable if we have ports with different MTUs. Well, we could do that, but there's a few issues here too. So first of all, we're obviously going to use more memory and initially, and we don't know that in the future another port's going to be added. We don't know that other port's going to be able to share a mempool with phi0. We don't know what the MTU of it's going to be. And if we just went ahead and did it and said, look, we'll take a chance, what would happen is we'll use more memory, and then what we could see is if somebody upgraded from an earlier version of OVS to this, suddenly they wouldn't have enough memory, and they'd have to change their provisioning. Okay, and that's never a good thing on upgrade to have to change things just to get the same behavior. So what if we could give a hint to OVS-DPDK? And that's what's implemented here. So In this case, we give a hint with this command, and we say 9000 is the MTU. So if you are creating a mempool for any DPDK device with an MTU of 9000 or below, please create the mempool based on the size of 9000. Because that way we can kind of say, well, if there's future ports added with different MTUs, we'll be able to consolidate onto this one mempool. Okay, so we add phi 0, we add phi 1, 1500, okay, keep using, 9000, keep using. So now we're in the situation that we wanted to be in. So just some more details. So it allows the sharing of mempools between ports based on NUMA, but it relaxes the restriction around MTU, and that's the key thing. We've just done something simple here saying 9000, but really you could have any number of MTUs if you wanted to, and you could specify the NUMA node. But obviously you don't want to make it too complicated either. So it's available in OVS 3.0. The defaults are unchanged, and that's because we don't want to break upgrades. It requires a user hint, that we saw the command for that. And you might ask, well, what happens if someone sets an MTU to 10,000? Well, it'll fall back to the existing behavior. And the other thing to mention is that the hint is only for when mempools are created. So we don't create mempools earlier. It's just at mempool creation, normal mempool creation time, the hint is checked. Okay, so the other feature, delayed vhost mempool creation. So for a vhost user port, what used to happen is, similar to the physical port, we would create a mempool if we needed it when the vhost port was added. But unlike the physical port, we don't need to send the mbuffs to the NIC, or in this case the vhost port, to populate receive rings. Okay, so we didn't really need to create the mempool at this point until we actually start receiving traffic from the vhost port. And furthermore, when we boot the VM and attach the vhost device, what we might find out is that the mempool that we created is on the wrong NUMA node. So when the VM boots on NUMA 1, we have NUMA reallocation in DPDK, and we realize, okay, we've created this mempool on the wrong NUMA node, and we change and we create a new one on the right NUMA node. Okay, so a much simpler thing to do would be just when we add the vhost user port is do not create any mempool yet and just wait. So delayed vhost user mempool creation. And when we boot the VM and we have the NUMA information of where the VM, so the VM is running on NUMA 1, it's using memory on NUMA 1, then we can create, and as the guest is booted, we know we want to have a mempool, so we can create the mempool and we can make sure it's on the right NUMA node. So this avoids creating a mempool before it's needed. It also avoids creating a mempool, where it ends up to be on a NUMA node that we didn't need it on. And that might have some implications depending on user config in terms of provisioning memory to different NUMA nodes. So this is the default in OVS 3.0. And there's some more information in the link below if you want more details on that. Okay, thank you.
All right. Thanks, Kevin. I believe that Kevin is online on BlueJeans.
Hi, everyone.
Oh, hi, Kevin. How are you?
Good, thank you.
If anybody has any questions for Kevin, we can go ahead. Anybody in the room? Questions? Or online? Do not see any hands out here. Going once. Going twice. All right, I guess we're moving forward. We're gonna all set virtually. All right, I guess we're gonna move forward to the next presentation.